All right, so let us continue with the question. So we have found the heat inputs and outputs for the processes A, B, B, C, C, D, and DA. Okay, so the values were obtained in the previous video. Just going to take you through a bit. Okay, so because you have the video, for you it's just going to be a continuation. So now that we have obtained all the heat inputs and the heat outputs, we can actually sum up. Let's say we find the total heat input for the system and also the total heat output of the system. So the total heat input here, we're just looking for those positive values. All right, the total heat input is just the positive heat, which will be regarded as the heat that was added to the system in this case. So we have the heat during the process AB. Okay, the heat during the process AB plus the heat during the process BC. Okay, so these were the positive values of the heat of the system. So these add up to give the total heat input. Okay, so we add the values. We have 15,190 plus 50,632 joules, giving us a total of 65,822 joules. Okay, so this is the total heat input for this system. And if you want to find the total heat output, more like the heat that has been lost, we look at those negative values that we obtained while we were solving. So meaning that the total heat output are the heat that we found during the process CD, and also the heat that we found during the process DA. These are the negative values. Therefore, we have the total as negative 30,379 minus 25,316. Okay, so giving us a total of minus 55,695 joules. So this is the total heat output of this particular system. So now let's go ahead and solve, or rather find the work output. Okay, so how do we find the work of this system? So the first thing we need to know is that work is given as pressure times the change in volume, right? So this is the work. So what this implies is that for those processes that have constant volume, there is no work. Okay, if we draw our cycle, we draw our cycle, we have A, we have B, we have C and D. Okay, C and D. So the volume during process A and B here was constant. Okay, and also during the process CD, the volume is constant. Therefore, the work which is done during process AB is the same as the work done during process CD, and it's 0. So there's no work done because there is no change in the volume. Okay, but if we consider the process BC and the process AD, or dA. So the process BC, the work done during the process BC, because there's a change in volume, okay, the work done during the process BC is going to give us the pressure, which is 2 times 1.03 times 10 to the power 5 pascals, multiplied by the change in volume. The final volume there was 0.2 cubic meters, and the initial was 0.1. So 0.2 minus 0.1, giving us the work done during process BC as 20,260 joules. Okay, so this is the work done during process BC because we have a change in volume. So during process DA, the work done during process DA is going to be the pressure. What was the pressure during process DA? We had 1, okay, multiplied by 1.03 times 10 to the 5, and the change in volume there, the final volume, because we're moving from D to A, the final volume is going to be 0.1, and the initial will be taken as 0.2. So you can see here that we're getting a negative work, which is negative 10,130 joules. Okay, so this is the work during the processes that are not at constant volume. Okay, now to find the total work output, we're simply going to add all these values of work, and we only have 2 in this case. Okay, therefore we're going to have 20,260 plus negative 10,130, giving us the total work output as 10,130 joules. Right, so this is the total work output of the engine, or rather the work done by this engine. So now that we have obtained this, it has become easier now to find the efficiency, since efficiency is given as the work output over the heat input. Okay, so remember the total heat input that we found. Make sure you go back with the video, you're going to see the value. So the work output that we have is 10,130 over the total heat input that we found was 65,822. So you multiply this by 100%. So that should give you the efficiency of this engine. Okay, so that's how you go about this problem. If you are given a heat engine and you are taken through all those cycles, just follow the steps that I have given in this video, and you should be able to solve it. Okay.